Okay, so now we will be talking about geometric series. So we have the formula of geometric sequence. It is denoted by S sub n is equal to a sub 1 multiplied by r raised to n minus 1. Then you will divide it using r minus 1. Here again, we are talking about S, and S is known to be your series. Okay, a sub 1 is our first term, then our r is known to be our common ratio. Then again, n is the position of the term that will be solved. Your minus 1 in your numerator and your minus 1 down below, or place in your denominator. These two are constants. You cannot change it. Okay, so let's have an example. Let's say we have 5, 25, then 125, and so on and so forth. You're going to look for, let's say, what is the value of, or the sum of the first 10 terms of this. So this would be denoted by S sub 10. Always remember, if we have your capital letter S, that means to say that you are going to find out the series. Series is simply getting the total. You are going to find the sum. So now, if we will define a geometric series is defined to be, this is the sum of all the terms of a given geometric sequence. I'll repeat, it is the sum of all the terms of a given geometric sequence. Now, based from our example, we are going to find out what would be the sum of the terms if we will add from a sub 1 from the first term until we reach our 10th term. Now, we are going to apply this formula. So we have the formula S sub 10, of course, because we are going to find out the sum of the first 10 terms of this given geometric sequence is equal to a sub 1 would be equal to 5. It's equal to 5. Yet, we are going to look for our common ratio. Again, our common ratio is, we have a sub 2 divided by a sub 1. And our common ratio now is equal to 25 divided by 5 is equal to 5. So 25 is our second term and our first term is equal to 5. So the quotient between your 25 and your 5 is equal to 5. So simply replacing or substituting the value of r in our formula, this would become now 5 as our first term, a sub 1, then r is, we have 5 raised to, it's equal to 10 minus 1. Okay, then we have your denominator. Our denominator is definitely the difference between the common ratio and 1. So we have 5 minus 1. So S sub 10 is equal to 5. Then we have 5 raised to the power of 10. We have 5 raised to the power of 10. What do you think is the answer? 5 raised to the power of 10, it's equal to 9,765,625 minus 1. Then divided by 4. Then S sub 10 is equal to, we are going to subtract first. We are going to subtract this by 1. So 5 times the difference between these two numbers. We have the answer. We have 9,765,624. Then divided by 4. Okay, let's continue solving this or simplifying this. Now let us multiply 5 and 9,765,624. We are going to multiply that by 5. So that would result to 48,828,120 divided by 4. So now we're almost finished. Let us divide 48,828,120 by 4. So dividing that by 4, so we have 12,207,030. This is now the sum of the first 10 terms of this geometric sequence. So this is now your S sub 10. It is equal to 12,207,030. Okay, let's have our second example. Let's say we have 20, then we have negative 80, then we have 320, and so on and so forth. We are going to find out, let's say for example, the sum of the first 8 terms of this. So what would be the answer? So first, we are going to find out our common ratio. So our common ratio here, after identifying our a sub 1 is equal to 20. Then our common ratio is equal to a sub 2 divided by a sub 1. So we have negative 80 divided by 20. So the answer here is negative 4. That is our common ratio now. That's the value. So we have S sub 8 is equal to, we have our a sub 1, it is equal to 20 times r raised to the power of n, which is our r is negative 4 raised to the power of 8 minus 1. Then all over, we have r, which is negative 4 minus 1. So S sub 8 is equal to, we have 20 times, what is negative 4 raised to the power of 8? So negative 4 raised to the power of 8, that would be equal to negative 65,536 minus 1. Then dividing it by the difference between negative 4 and 1. So the answer here would become negative 5. Negative 4 minus 1 is negative 5. Then S sub 8 is equal to, we have 20 times the difference between this, negative 65,536 minus 1. We have negative 65,537. Okay, divided by negative 5. So we are going to multiply now. So we have to multiply 20 and negative 65,537 by 20. We will multiply that by 20. So the answer now, we have S sub 8 is equal to, we have negative 1,310,740 divided by negative 5. So S sub 8 is equal to, now we will divide by negative 5. So the answer now is equal to 262,148. So the value of the sum of the first 8 terms of this geometric sequence is equal to, we have 262,148. So always remember that getting the first the sum of the first nth term, that would always talk about series. So again, a geometric series is known as getting the sum of the terms in a geometric sequence. And always remember as well that your common ratio should not be equal to 1, because if your r is equal to 1, then it is indeterminate, which means to say that it is undefined. Okay, so this is now an example or examples of how to determine the the geometric series of a given geometric sequence. So that's it. Thank you.